gentlemen. Uh, so this is the topic, the title of the talk. So let me just, so before entering the talk, let me just ask you a question. So how many of you sitting here can confidently say that, I understand the basics and the fundamentals of character encodings? Not just as a Ruby programmer, but in general. Okay, 1, 2, 3, right, 4, 5, okay, not many, right? So a lot of people asked me like, why did I choose this topic, right? So I think this is the reason why did I choose this topic. So this topic is very important, like understanding character encodings for any programmer is actually very important for them to become a good programmer, right? But even today, a lot of programmers don't understand the fundamentals of it. And the reason for that is you actually don't encounter a lot of problems in character encodings unless you try building a multilingual software, or an international software, international web application which works in multiple languages, right? So that's the reason you don't usually, want to learn character encodings. But I strongly recommend that you should understand the fundamentals of it, because in today's world, today's internet age, there's a lot of data exchange that's happening between a lot of computers, right? And computers understand bytes. And if your programs don't do that byte representation properly, then your program is going to mess up. And a lot of people will see different data, which you do not intend to. So let's go and check it out, like what are character encodings and what are the fundamentals of it, right? So first let me introduce myself. So I am Satish Perala. I work for a company called Cybrilla, and that's my Twitter handle. By the way, I am not a guitarist. So this is just a pose given by me for a photo shoot in my office. So don't ask me to play guitar in the after party tonight. So before I delve into it, I just wanted to show these pictures. I know most of you guys know who these two are, right? So the one on the left is Joel Spolsky. So why did I put these pictures is basically they have written nice articles on character encodings. So Joel Spolsky has a very interesting article on character encodings and the fundamentals of it. So and JEG2 has articles written on how character encodings are supported in Ruby, right? So if you are interested in character encodings, right after the talk, go check out those articles. They are very informative, and I learned a lot from those articles, right? And this talk content is basically prepared based on that. I've enhanced it a little bit. For the context, right? So first let me tell you that this talk is not about internationalization or localization. So as a web programmer, I understand that what are these two, but I'm not going to talk anything about these two. These are very important topics, but these are very high level. We're going to go deep and understand the basics of encodings. So I believe that to understand any concepts at a fundamental level, you need to understand a little bit history on how did a concept evolve, why did it actually exist in the first place, and also a little bit of terminology, right? So there are a lot of terms used in character encoding. So I'm going to introduce you to all of these by telling a story from the history, so that you better remember why did character encodings exist today and why it's all a mess. So back in the very old days, when computers were primarily used by English speaking people and majorly sold in the United States. So the primary purpose for computers at that point in time is to digitize a lot of text documents in the United States and then probably exchange information, telegraphic messages between different computers. So that was the major use case the computers were used for. So at that point in time, if you look at the number of characters which people thought that they would require or the computer required to understand is this set. If you look at this, you have capital letters, small letters, English alphabets, numbers and basic punctuation marks. So these are pretty much enough to digitize any text document available at that point in time, right? And probably a few other control characters to send signals to printers, for computers to print documents. So if you look at this, so people never thought that they would need characters out of this character set here. They never thought that there are other languages, people speaking other languages who would want to use computers, and probably they need more characters to put as a part of the character set. So people have come up with a name to this character set, and they call them ASCII. So let me tell you what is a character and a character set. So these are important terms which you need to understand, right? Because the entire character encodings world, there are a lot of misnomers. So if you don't understand what each term is, then you understand it little differently. So character is nothing but any representation which has some knowledge in the human language, right? So that's like alphabets, numbers, punctuation marks, any symbol, like even dollar, pound symbol is also a character, right? And character set is nothing but a group of characters, right? So ASCII character set is a group of these characters. So what they've done is they've given integer to each of the characters. So character A has got 65, small a has got 95, 0 has got 45, so that, so if you look at the total number of characters in that ASCII character set, it's 128, right? So 128 has a relevance here, let's go and check it out why. So if you look at the byte representation of character A, so it's 01, 00, 0001. So all these 128 characters or the 128 integers can be represented in one single byte. And you wouldn't need the 8th significant, like the last significant bit as well, right? So if you look at small a, this is how it is represented. So this is the last character in the ASCII character set, which is represented as 0 and all ones. So if you closely observe, the first bit which is there is always 0, right? So what that means is, so that is unused bit. Since we have only 128 characters and people thought that they wouldn't need any more characters to be part of the character set, so this bit is unused. So there are other 128 to 255 numbers which are unused, which totals to 128. Now comes the interesting part. So it's all good, like people were using ASCII and all, but now since there are a lot of unused integers as part of that byte, people started putting their thinking caps, and then they started assigning their own characters to those numbers from 128 to 255. So it's all fine until one person thought of one definition. There's another person who came and thought another definition. Probably he's speaking another language, have another set of characters to represent in 128 to 255 numbers. And like even people who don't understand computers well also came into the picture. They defined their own encodings, they defined their own definitions of what should go, right? And then slowly, like people across the world, right? Computers got sold into different parts of the world, and people speaking different languages started using computers, and everybody has come up with their own definition. Because of that, now there is a mess. So let's take an example here. So let's say somebody is sitting in the United States is sending an email to somebody sitting in Israel, right, the Asian country. So this is what happens if he sends a email which has the content resume with the accented E. So that is how it looks in the computer in Israel. So why is that? Why is that happening? So that's because, so the computer in USA, the guy sitting over there has defined that accented E would be represented as 130 in his computer memory, right? So the guy sitting in Israel thought, okay, so 130 I will use for some other character lambda, and he represented that. So when bytes were exchanged between these two computers in the form of email, the content you read and display to the user is actually different, right? In this way, there's a lot of data which is lost because there is no common agreement between how a character should be represented in computer memory. So like everybody has their own definitions. So before Unicode was born, so other interesting problem which came up is, so there's a lot of Asian languages have characters which are like goes into hundreds and thousands of numbers, right? So there is no way you can actually represent that in one single byte. So the 128 integers which were left over is not enough for any Asian language to fit in their characters. So people started inventing other ways of representing it by using 4 bytes, 2 bytes and all. So they've created a lot of definitions of using it, but there is no common agreement people agreed to. So then came Unicode, right? So much later into the picture, Unicode has come. So what is Unicode? So there's a common misconception among people that Unicode is an encoding, right? So Unicode is not an encoding, right? Unicode defines, few encodings for its characters to represent in byte memory, but Unicode itself is not an encoding. So what is Unicode? Unicode basically attempts to bring all the characters available in this world, all from the modern language, ancient languages, all representations, all symbols. So it has attempted to bring all those characters which we would ever need into one character set, similar to ASCII. So they have a huge character set which covers pretty much every character available in this world. So that is what they've attempted to do, and what did they do is they've taken a little different approach in representing it. So if you look at how Unicode characters are represented in the internet, like you find these kind of representations in a lot of internet material when you read about encodings and all. So it's good to understand what it is. So when character A is represented as U plus 0041, so U plus represents it's a Unicode character, 0041 tells that's the hexadecimal value of that character. So every character in the Unicode character set is given an integer, which is given a unique integer value and a unique name to identify those characters. Right? So those unique integers are called code points. So code point is also a interesting term which you will find across internet, so it's good to understand that. So the value given by the Unicode consortium to each character is what a code point is. So similarly, small a has got U plus 0061 and 0 has got this. So what is a coded character set? So Unicode consortium says that it can fit almost 1.1 million characters in its definition, right? But today only 10% of that is allocated. So around there are 100,000 characters available in this world which are given code points. So that character set is called coded character set. Cool? So now the thing is, Unicode has given a definition, assigned integers to each character, but it didn't talk anything about how it should represent in the computer memory. So it didn't talk about what bytes in the computer memory each character should be represented. So there comes the encodings part. So today there are lots and lots of encodings available in the market. So there are a lot of pros and cons to each of them. So I'm not going to dive deep into each of them, but we'll just look at these three encodings which are defined by the Unicode consortium and most widely used by majority of people in the world. So UTF-16 is the one which is born first, then came U32 and then UTF-8 was born. So there's interesting thing which you need to understand. When Unicode was born, it was not widely adopted immediately, right? So that's because when Unicode was born, when it came into picture, there were lots of English documents which were written using ASCII encoding. So if people had to adopt Unicode with whatever encoding definitions they have given, it means that we have to go back and change all those digitized documents using Unicode encoding. Otherwise, there would be a big mess. So people were not ready to do that. You wouldn't ready to do that, right? Because a lot of documents have been written and there is no point or there is no need to convert them into UTF encodings. So the adoption of Unicode only became wide only after UTF-8 was invented, because UTF-8 ensured that there is a backward compatibility to the ASCII. So what it means is UTF-8 says that if you look at, I've taken an example with 4 different characters. If you look at character A, and then there are 3 characters, one is Hebrew, one is Japanese and one is Chinese characters. So if you look at how they are represented in different encodings. So UTF-8 makes sure that the characters in the ASCII character set, which are the alphabets and the integers and all, they are only represented using 1 byte, which is exactly the same as how it is represented in ASCII. So there's no need to change all those documents into UTF encoding even if you start using UTF-8. So that's the main reason people started adopting Unicode, and today if you see UTF-8 is the most popular encoding available. I guess most of you sitting here are web developers. So across internet, like when you exchange information, when your web server responds with HTML data, UTF-8 is the most widely used one. So if you look at the differences between UTF-16 and 32, UTF-16 says that I will store all characters in 2 bytes, and wherever it doesn't fit, I'm going to switch back to 4 bytes. So that's what UTF-16 says. And UTF-32 says, don't worry about all that, I'll store everything in 4 bytes. So there are pros and cons for that. So nobody prefers UTF-32, especially the English-speaking people, because in ASCII, if you write same content, it would take 2 bytes, and in UTF-32, it takes like 8 bytes, 4 times the memory, the hard disk it uses. So that's the reason nobody prefers UTF-32. So that's a little, input on what encodings are. So even after this, there are lots of people who ask me, so what? So as a programmer, why should I care? Now you understood the fundamentals of it, but like, what if you don't understand it, right? Because you never encounter problems. So the reason for that is I have a couple of reasons why you should understand it. One of the important reasons is there are many encodings. If the entire world is using only one encoding, which is UTF-8, then there is no issue. So you don't have to understand the fundamentals, it just magically works. But since you have like lots and lots and hundreds of encodings available in the market, if you have to write a program, right, which has to work across different languages, people speaking different languages, if you want them to use your software, then you need to be aware of the fundamentals of it. Otherwise, your software is going to make a mess. This is what will happen if you don't understand it. So you send data, and then it starts showing up in other computers with different data and probably loss of data. If you look at the second line, that's the usual character you'll see in a lot of web pages. I guess most of you have seen that. So that means that the computer which is reading, the program which is reading, doesn't understand which encoding it is in. So that's the default character which is getting displayed. So this is what happens if you don't, write your programs which understands encodings better. So let me ask you a fundamental question. Can anybody here answer this question? Anyone? Yeah?
Not compile, because you have not used the proper quotes, the compiler will fail.
I didn't understand.
This code will not compile.
Code will not compile? Oh, okay.
Yes, you have not used the right quotes. You've used the word quotes.
Okay, sorry for that. So this was not a code actually. So anyway, so the answer to this is there is no way you can actually tell which encoding it is in, because the data which is there, it actually doesn't have any encoding tag attached to it. So today if you're given a data, if your computer is given some data, unless it is told that which encoding this is encoded in, there is no way your computer can figure out. Cool? So there are different ways to tag data. So if you look at email headers, you can actually go check out your email headers by looking at the original message in Google, Gmail. So you see this, there is a character set UTF-8. If you look at HTTP headers, there is something called char set. In HTML meta tags also you have. You might have ignored all of this when you're writing your web programs, but these are very important. If you look at XML prologue information, that also has this encoding information. So different ways you can tag your data with encoding, but if you look at all the data available in the world today, it's not tagged with any encoding. For example, all your text files in a computer doesn't have any encoding tag attached with it, but you can actually read all those data, right? So that's because it can also be guessed, which is not 100% foolproof, but there are programs which tries to guess based on the byte representation, byte sequences, it tries to guess which encoding your data is represented as. So one such command is file command in your Linux, which will help you do that. So I'm going to skip this. So fine, now we understand the fundamentals of it. So let's try to figure out how Ruby handles it. So Ruby actually handles or supports encodings interesting way compared to other programming languages like Java or Python. So, so I'll tell you what is the difference going forward. It's good to understand what is the support Ruby has before 1.9 and after 1.9. So before 1.9, any data which is there in any Ruby program doesn't have an encoding tag. So all the data in your Ruby programs before like 1.9 version is actually pure bytes. So it's actually left to the developers to figure out, read the bytes and figure out what it makes sense. So for example, if you look at the same string, string is equal to resume, and then look at the size of it in Ruby 1.8, it will actually show as 8, which should be 6, right? Because Ruby 1.8 doesn't understand, it treats every data as byte representation. So if you look at accented E, it is actually represented using 2 bytes, and this, so that's the reason the size is 8. But if you look at Ruby 1.9, they've taken a different approach, and then they started supporting character encodings very strongly. And so they've done it a little different compared to other languages. We'll understand that. So we just need to know this class, which is actually the core class for all encoding related stuff in Ruby. So so the better way to understand it is look at some programs and see how Ruby supports character encoding. So let's dive into it. So let us look at this program which I have written. If you look at the let me do that. Better? Yeah, so if you look at this, so if you look at the second line, so I have defined a string which is written in Hindi as Ruby. So, and I printed what encoding it is and what size and what byte size it has. So if you look at this, if you look at the output of this, so the output of this says, so the variable str is actually encoded in UTF-8. So you need to know who has given that encoding tag to that string, right? So there is something called source file encoding in Ruby. So by default, the source file encoding is UTF-8 in 2.1. So Ruby greater than 2, the default encoding is UTF-8. So that is the reason the string is assigned UTF-8 as the encoding. And if you look at the size of it, it is 4. So why is it 4? Because if you look at the characters of that are used to represent Ruby in Hindi is R, and there are 2 characters which those dirghas and then ba. So if you look at this, there are 4 different characters that are Unicode characters which are used to represent Ruby word, right? And if you look at the byte size, it is 12. So each of these characters have taken 3 bytes in UTF-8 encoding. So this is how you use Ruby to support encoding. So let's look at another example, which is, so Ruby also allows you to define your own encoding for your source files. So that is a magic command on the top, which allows you to define which encoding your Ruby file, source file is written in, right? So if you look at this coding, I've written ISO 8859. So all the strings which are created as part of this file will get ISO 88591 as the source file encoding. If I just run this program and show you, this is what you get. So the encoding is this. If you look at the size of it, it is 6 and the byte size is 6. Why the byte size is 6? Because in this encoding, it only takes 1 byte to represent all this, all the characters, English characters as well as the accented E characters. So forget about why is that question mark is coming here, but actually depends on the terminal which you are using. If your terminal doesn't support this encoding, it doesn't show up. So let's see So in your programs, you always find a need to change the encoding of different strings. So Ruby gives you two options to do that. One is force encoding, which using which you would tell Ruby that, okay, you don't worry about the encoding, I know which encoding it is in. So you are actually forcing Ruby to consider this data as in a different encoding. So it actually don't change the byte representation, but it only just changes the attached encoding tag. If you look at this, the string I have created in UTF-8, which is called Résumé with accented E, it has size as 6 and byte size as 8. But if I just force Ruby to change that encoding into a different encoding, this size has actually become 8, right? So that is because you cannot actually force encoding on data which you don't understand. So if you look at it, it has become 8. So it is actually taking byte representation. So accented E is actually considered as two different characters when you do force encoding. So there is a better way of doing this, that is called transcode. So if you look at transcode, you are actually telling Ruby to change the byte representation of the data. So if you look at this string in UTF-8 as Résumé with accented E, and in let me show you the line. If you look at line number 7, I am trying to transcode the data. So Ruby gives you a function called encode, which takes the encoding name and transcodes the data, which means it changes the exact byte representation inside it. So if you just run this program and see, so now you look at the size of that Résumé word in ISO 8859 encoding, it comes as 6. So this is actually a better way to transcode data in your Ruby programs. So now comes an interesting part. So this is all in your program, right? But when you write programs, you actually have to read and write data from external sources. So how do we handle encodings from those perspective? So let us look at another program like this. So there is something called internal and external encoding which Ruby gives you. So what external encoding says is, whatever data you read inside a Ruby program, the encoding tag which comes attached with that program, with that data is called external encoding. And internal encoding is something which you transcode that data into. For example, if you decided that in all your Ruby programs you want to do concatenation of strings or a lot of other operations on string in only one single encoding, so you set your internal encoding to one standard encoding, and then you transcode all of your data which you read into your programs into that internal encoding, and when you write out, you actually write into the external encoding. That's how you handle it. So if I just run this program, yeah. So if you look at this, so this is how you represent the external encoding. So I'm actually opening to read the same file in a read mode, and I said UTF-8 as the external encoding. So it means that this file is encoded in UTF-8 and you read that in UTF-8. So when I try to print that, each line or each string which I extract from that code is given an encoding tag, which is UTF-8 by default. So if you want to transcode it, if you want to have an internal encoding which is standard, so you can actually set so if you look at how this is changed, this is how you do it. So if you do a colon ISO 88591, so you are actually setting an internal encoding to that data. What this means is, whatever your data you read, you actually transcode that into internal encoding, which is ISO. So if I run this, this is how it happens. So previously, all the strings which were extracted out of that file were tagged with UTF-8, but now it's tagged with ISO 88591. That means that you've asked Ruby program to transcode all your data into your own internal encoding, right? So that's how you do it. And similarly, you can write your data into external files using whatever encoding you want. So external encoding also plays similar role here. So whenever you start writing your data out, so if you look at this program where I am writing resume into an output file. So if I just run this program and then check this. So this command file will tell you, will guess the encoding in which the file is encoded in. So if you look at it, it is encoded in ISO 8859. That's because the external encoding is set as ISO 8859. Right? So this is very tip of the iceberg of what and how Ruby supports character encoding. So I recommend you go read JEG2's articles on character encodings deep, which will actually make you a better programmer if you want to write multilingual software in the future. So let's go back. So what is the difference between, what's the difference, like how is it handled in Java or Python? So as I told, Ruby handles it in a little different way, right? So if you look at Java or Python, they have said that we're not going to support all these encodings. We're going to set one internal encoding, and all our programs are going to use those encoding for all internal operations. So that's similar to what internal encoding is in Ruby. If you look at Java, it sets UTF-16 as its internal encoding, and whatever data you read into Java or you write, even if you read UTF-8 or even if you read ISO 8859, it's going to transcode that data into its internal encoding, which is UTF-16. So whenever you're manipulating data inside Java programs or strings operations inside a Java programs, it is entirely handled in one single encoding. But Ruby is not like that. Ruby actually allows you to do whatever internal encoding you want it to. Okay, and I think the primary reason behind that is because of the big Japanese Ruby community, right? The reason being all this, so from your so in Japan, Shift JIS is the encoding which is like the most widely used one. So there's no round trip available from all the characters in Shift JIS to UTF-8 and come back. So let's say in Java, if you transcode all of that data into UTF-16, and then you have to transcode it back to Shift JIS, there's a lot of information which is lost, which obviously the Japanese community didn't want to. So that is the main reason why Ruby has taken a different approach and said, I leave it up to the developers to go figure out what internal encoding you want to use as, right? So there's no hard and fast rule that what way you should follow or what internal encoding you should do. It actually depends on which, like who are going to use your software, who is your target audience, and where is your software getting used. In that way, you're actually going to figure out and choose your encodings wisely, right? That helps. So that's about it. So these are the photo credits I've just put. I think I can take questions if you have some time. Yeah.
Thank you, Satish. Do you have any questions for Satish here? Nobody?